management. How's everyone doing? How are you doing with respect to assignment 2?
Yeah, getting through it.
Okay, that's good. I hope that most of you have started. We have one more week, right, before the deadline. So if you have any other question, you can ask now before we get to the content of this week. Yeah, chipping away. That's the way to do it. Okay, so this week is the first part of the two-part lecture on risk management. Okay, and I remember at the very beginning in the first lecture we discussed why cybersecurity should be treated as a risk instead of a problem to be solved, right? And maybe after 6 weeks we all get new perspective to appreciate that fact, and it's a good reminder to it's good to refresh our mind on why this is the case. So let me put this question to you: why do you think that cybersecurity is a risk problem rather than a problem that have a complete solution? Because when you talk about risk, it seems to imply that it cannot be entirely solved, right? And the question is, why do you think that is? Why can we not have a solution to cybersecurity and be done with it? Why do you have to treat it and manage it as risk? Yes, Andre.
I think, first of all, because it's a factor of unknown, we don't know exactly where the problem can be, and because it's ever changing, new threats are discovered constantly. We don't know the future. We cannot predict the future, so we can only prepare ourselves the best for it. But there's always be a factor of what something we don't know, something we don't expect would actually be the cause of the intrusion or some problem.
Okay, so the point is uncertainty, right? There's some uncertainty that we don't know about. But let's assume that we know that this is a problem. But can we just solve it and not treat it as risk? Is there any, is there any difficulty in doing that?
Yes, there is, because again, the biggest part of the security is still dealing with people, and people are not reliable by definition. So you can't expect them to do the right thing all the time. They're not robots. They do mistakes, and those mistakes can be the cause of the problem.
Okay, so you make a good point that it's not solvable because human make mistake, right? Human cannot be trained not to make mistake. Okay, I think that is a good point. Yeah. Yes, Connor, you want to add the own viewpoint?
Yeah, well, I think we take a risk managed approach purely because every organization or every business has got a different appetite,
Yeah.
And even that appetite changes depending on what executives you've got, whoever's running the show at the time. And that allows them to still, I guess that's the difference between a compliance framework versus a risk-based framework, is that a risk-based framework allows for the acceptance of risk as well.
Yeah.
So, assuming that they're happy to take on the accountability, they're allowed to have whatever risks they want, really.
Okay. Okay, so it's more, yeah. So you talk about accepting of risk, right? But that assume that we accept that we have to treat it as risk. But the question, my question is a bit, I think, lower level is, why do we have to treat it as risk? Can we treat it as a problem where we can buy some solution for? Or why aren't there a solution for all of this cybersecurity problem? Because when it's when you talk about risk, we seem to imply that something cannot be solved, right? And I want to poke a little bit. You think like what cannot be solved? Because Andre gave one good interesting point that human can always make mistakes. There's no solution that force human not to make mistake. That is a good point. Yeah, but is there any other reason that you can think of?
Well, I don't agree there because I think risks can be solved. I think, you can't. Yes, you probably can't solve all risk. Apart from locking yourself inside a padded room. But even as Andre said, then the human factor comes into it, and you can bang your head against a wall enough, and you'll still do some damage. But I think risks still, though, you have remediated risk. You have a risk that can be solved through technical controls and that sort of thing. So
yeah,
I think though risks allow for a life cycle, whereas if you treat it as if it's something to just be solved, it's pretty binary, and that's where you fall into compliance. Whereas a risk has a life cycle. It's dynamic. It can reappear. It can be revived. It can be remediated. It can be transferred. It can be moved around. Whereas, if it's just a problem, then it's pretty black and white. You either solve it or you don't solve it.
But isn't that a good thing? I mean, so right away that I solve this problem, so I don't have any problem anymore, rather than like living in the gray area, saying that okay, I'm pretty good, but in fact that you are not. So I mean, isn't like a binary solutions a good thing?
Well, not in our industry, because technology is moving so quickly that binary doesn't really exist anymore. Because as soon as you patch one thing, or as soon as you remediate one risk, something opens up another one. So
okay, yeah. So I think you share the same same point as with Andre's earlier about uncertainty, right? So it's evolving uncertainty. Okay,
yeah,
I will
it's
take that.
dynamic.
Yeah, it's dynamic. Okay, let's see what Andres have to add first, and then.
Two more points I actually come up with. First of all, not all the system is actually fully controlled by you, because you have to rely on third-party solutions, third-party code, which you usually don't really know how exactly that works, what's inside. So you will you obviously cannot guarantee that code is security free, risks free, that it's reliable all the time. And second, the sheer complexity of the task, even if you deal with the binary solutions, simple settings, because modern networks are so complex with lots of different parts. Their mistakes can kind of first of all accumulate, because you can maybe forget to do something here, something there, and this together on itself maybe not be a problem, but when they combine together, they create new ways to attack, which you might not even predict that this system can be used in this way. And that's what usually happens. Hackers usually find those loopholes, find those problems when system does not fully match to each other, do not fully cover certain area, and those cracks, that's where the attack can happen. So complexity of the thing, basically, because every system can kind of multiply the risk multiply in the system, that also creates a problem, which cannot be really solved.
Okay, so our first point is that we have to rely on some third parties, right? So let me counter it with example of like Google and Microsoft. They run their own things, right? They never have to rely on any third party software, for example. They can certainly develop everything in-house, but they still need to take the risk-based approach, right? So why do you think that is?
Even if they build it themselves, it's not one person. It's different teams, different divisions, and even probably then they not do everything in house. They still outsource, and probably outsource a big part of this by the modern world standards. So again, they have to kind of accept that whatever kind of they have to trust that technology, that it's been done properly, done with all the testing. But there's always a factor that this is not true, that this can be like you can't fully trust anything in the modern world.
Yep,
You
yep,
have to
yep.
always factor that this thing actually can break. In Douglas Adams' book, there was said that the only difference between things which cannot break and things can break is that when the things cannot break actually breaks, it's impossible to fix.
That's good quote. Yeah, I will come back to that, but let's hear Babak's.
I think for me, cybersecurity is not cannot be risk free. There's no perfect state,
Okay.
and one of the reasons is it's it's not an isolated function. It's it's a function that supports typically an organization, a business, or something, and that business or organization is dynamic and it's changing. It's dealing with third parties, different stakeholders, etc. And cybersecurity is mostly playing catch up in a sense that it's just there to mitigate some of the risks.
Okay.
Even in an ideal scenario, I think, for example, if we want to do a asset risk assessment, you could hope for covering most of your assets, but I think in a big organization, you rarely cover 100%. And each of those assets are upgradable. They need to be updated, etc. So I just think that because cybersecurity is not an isolated function, and I'm assuming we're talking about cybersecurity risk management,
Yep.
then in that case, it's there to support business essentially, and business has to deal with the outside world. It cannot be isolated. It cannot.
Yep.
It has to connect to the internet. It has to connect to partners. It has to connect to customers, and therefore there's a lot of exposure. It's just a matter of reducing risk for a period of time and trying to be on top of things. So yeah.
I think you have two very good gems from what you just said, Baba. The first one is about complexity, right? I think you agree with Andres about that point, which is complexity. When things work in a non-isolated way, when it depends on other things, then you have the problem of complexity. Am I interpreting it right?
Correct. There's
Yeah.
complexity, dynamism, and also the fact that there are so many stakeholders, and that could be internal, external, malicious, external, malicious, internal, in some instances. So even if you do technical controls, even if you do that, there's things like 0-day attacks which the vendor themselves couldn't assume. So all these technologies are meant to connect to an external party mainly, and therefore, because a business or an organization has to interact with external parties, expose itself to do that communication or transaction, there is exposure. It's not air gapped. It's like saying that you cannot have a computer that's air gapped, does not connect to the internet, does nothing, is just functions as singular. There's very few use cases that exist in the world today that's like that. Even OT networks are going out of this, and they're trying to figure out how to make it more IT centric, to be more serviceable, whilst making sure that critical infrastructure is not exposed. But it's not possible. You have to sort of to advance that technology, you have to connect it. So I think yes, it is the complexity, dynamism, but also I think it's because it has to cybersecurity has to serve other functions, which is the business or the objective of an organization. It is exposed.
Yeah. So that is a second key point of the discussion. I think the first one you said about complexity because it had to have many dependency, but the second one is that it had to work in service of some other. So for example, you have business to serve, right? And in real companies, I think the business goals and the cybersecurity goals are different. So for example, you can have a pretty good security solution by taking everything offline, but it's not going to work that way, right? It's not going to it's not going to serve business. So it's not it's not only about solving a cybersecurity problem, but solving it in a practical way too. And that additional constraint is just sometimes cannot be met, because even though if you have a solution that can solve the problem, but yeah, so business people will not buy it, right? So I think that is a very good point. Yeah, so I want to come back to what Andre said earlier about complexity, and which is shared by Babak as well. When I think the main idea here is that it's really difficult, right? It's really difficult, or like bordering impossible, to secure a system of such complexity. And let me show you this paper. Does anyone like hear this paper before, or this guy called Ken Thompson? Right, so he's one of the developer of C and C++. Okay, so one of the the founder, one of the the original developer of this language. And in 1984, he's published this paper, and in part of his Turing Award recipient. And basically, this paper set out the scene for computer security. And what he said, essentially, is that computer system cannot be secure. There cannot be a technical solution that makes sure it's secure 100% of the time. Okay, so it has been proven by some complicated trick here, but the key point that there's no solution out there that can 100% protect you from attacks, right? It's not possible. It's not possible. Yeah. So if someone come and sell you a solution to secure the system, then they must be lying. Because this guy in 1984, he said that the system cannot be secure, okay, unless you make some trust assumption somewhere, okay, and unless you trust some level and then build on top of that. But if you if you violate that trust, then everything just fall apart. Okay, and modern systems are really complex from the hardware layer to the software layers, and it's not even possible to secure one single computer. So it's not possible to secure the company system either. Okay, so I would put this one in the chat if you want to take a. It's a very classic work. I think most of research from computer security start from this point. Right. So yeah. So in summary, our discussion basically say that we have to treat cybersecurity at risk instead of a problem to be solved, because first of all, there's no solution out there that can solve it. I mean, if you look hard, if you try to formally define security, there'll be no solution out there that can meet that requirement. Okay, and I mean, the main reason you can read this paper, but some of the other easy to explain reasons are complexities and the ability to work together with the business to serve the business, right? And human as well. In fact, this paper also even mentioned human as one of the one of the threat one of the attack vector as well. So yeah, he anticipated that from 1984. So yeah, so that is why we need to treat cybersecurity at risk, because there's some things cannot be solved. You have to be managed, right? You just need to identify that risk and somehow manage it. Yeah. So Connor said, show me a single solution that guarantee your application in an environment will be patched rapidly. I think this is a rhetorical question, I guess, but it could give some of you some business idea here. Yeah. Is there some application that that do this?
Well, that's the rhetorical. It's like you said, because there's no one solution that can do it. There's you can get multiple solutions that might work together to achieve that result, but there's no guarantee either that any solution you look at actually support. What happens when you get a new application that comes in? Like, you know, what happens when there's a desktop version of Copilot? Which solution is going to be able to patch that straight away?
Okay. So, I mean, I'm not so sure about what happened in the industry, but there's no such solution at the moment. There must be a software that patches like a software patches a large number of computer in a networks, right? That's how like most of the enterprise manage their employees systems. They
Yeah,
must have
well,
some control, right, to do
well,
this.
there's systems like SCCMs or Config Manager. Patch My PC is another third-party application, that sort of thing. But they don't cover everything. That's the problem. They only support certain applications.
Yeah. And I think it's easy to imagine that some certain application will be out of date and be replaced by new set of applications, and then you need a new set of software to manage them. Yeah. So okay. Yes. So now I think this is a very critical takeaway that we need to understand why we need to do risk management in cybersecurity. Now we understand why. So let's take a step back and understand what cyber risk is. Like, let's try to define it so that we're on the same page. Okay, because different people have different definition of cybersecurity risk. So it's better that we follow the same definition. And this definition is it's quite well written, actually. A cybersecurity risk is defined as a likelihood. I think we can just use the word probability as well here. I think as a probability of a threat exploiting a given vulnerability of an asset, potentially causing a loss and damage to the asset. Yeah. So there are a few keywords that are actually highlighted or underlined here. So the cybersecurity risk is a probability. Okay. So it means it is a number somewhere. It is number from 0 to 1, right? And so it's the likelihood of a threat exploiting a vulnerability of an asset. So what it means is that one asset may have many different risks associated with it, right? So because X risk has to be defined with respect to a particular threat. So one asset may be subject to many different threats, right? And each of the threat carry different risk. Okay, so yeah, so this is important to agree on this definition here. But I would like to hear from you guys. Have you got any other definition of risk? I mean, when you work on the risk management domain, do you guys use any other formal definition of what risk is? So from this definition, it looks like it's a likelihood. So this is a number, right? 0 to 1 to me. And that number depends on the asset being exploited. One of the vulnerability of the assets being exploited for a threat. Okay, so the probability of a threat happen to an asset because this threat exploit a certain vulnerability associated with that asset. Does it make sense to you? I mean, it's quite long-winded, but I want to pause it to see if you have any question or comment, anything not clear about this definition. Right? Good. Yeah. I think the likelihood is important here because this is defined as a number, right? So if we can treat anything as a number, then we can feed it into some software and do number crunching. So that's good. Yeah. Right. So it's a good way to visualize it. Is to have this diagram here where risk is some point in this space, right? So it depends on the likelihood and the impact as well. So what we want is to go to this lower corner on the left, which is low risk, which means that the probability of that happening of that of the threat exploiting this vulnerability happening is very low, and even if it's happened, the impact of that threats happening is quite low too. Yeah. Okay. I think we will come up with plenty of example later. Okay. So risk is like this, right? Risk is defined as this. So can you now let's take this definition and let's think about why risk management in cybersecurity is challenging, it's difficult. I mean, why can some random people off the street without any training in the cybersecurity and not even working in the company can not do risk assessment for the company, risk management? I think we come to risk assessment and risk management later, but can you, from this definition and from the experience, share with us, like, why do you think cybersecurity risk management is not easy? Yeah. So this is what the risk is, right? But to manage risk, to manage cybersecurity risk, what do you think it entails? What do you think that job entails? And why they are difficult? Why they are not easy to do? Yeah.
Like
Given
we
this component
discussed,
of a risk. Yeah. Yes, Babak.
given similar to our previous discussion, it's a matter of complexity
Mm-hmm.
and knowledge of the environment, the systems, the business,
Okay. Yeah.
experience, and also, in fact, these are all privileged systems, so it has to be an internal party or a agreed upon external party, like let's say a external pen tester or auditor.
Yeah.
So it's not a simple thing to do. It's just complex.
Can you base that? Can you base your analysis on like the definition of cyber risk here? I mean, which part of like some of this highlighted stuff here is complex, or which stuff is like which stuff needed a privilege to perform?
I guess all of those highlighted areas are complex. Risk is complex. Likelihood requires analysis and knowledge of the asset, its vulnerability and potential threats. All these are very technical.
Yeah. Why is the
knowledge.
assets complex? Why is managing assets complex?
Oh, it's because there's a wide variation of assets. Each of those are unique in a sense. Even laptops can be different. A laptop for an IT admin will have different privileges versus, let's say, a salesperson. So the dynamism of each system, and then each system, hardware has software as well. It has network components. There's so many layers that it's just not something a layman can understand these things.
Okay.
And in fact, it's not even a single person job. So
that is true.
It's a function of complexity, I think.
Yeah. So
Sorry, Connor,
so complexity here is defined as there's a large number of assets, right? So it's complex in the sense that there's so many of them to go through. That is the complexity with assets, right?
Yeah.
Okay. So how about for threats and vulnerabilities? Do you want to do you want to add on to it, or let's see if other want to?
Yeah, sure.
Explain.
Connor, you want to go for it?
Yeah, Connor.
Yeah, well, I agree with Babak there that it's very much the same with the threats and the vulnerabilities, that it's the complexity of them and the fact that a threat could have, so I deal with, in my day-to-day, using the ISMS that we manage, you have a risk, and a risk is typically fairly high level. And we'll say, something like, database A could be breached, because risks you need to also be able to convey to your executives pretty clearly. But we then break down the risk into multiple threats or issues. And then so you sort of end up with a one-to-many relationship there where you know, you have one risk that could have many different things that could lead to that risk occurring. Or you could probably do it the other way around if you wanted as well. You know, it depends on the approach you take. You could try and say there's super detailed risks that are a result of super detailed threats and have a one-to-one correlation. But, you know, the register that you would have to maintain and the how big of a database do you want to create when you're having to deal with that? Because as Babak said, like when you start thinking about assets, you know, define an asset. Well, an asset could be seen as hardware, software, data streams are an asset as well. So, you know, if you're taking data input or even a form that you're receiving from customers, that's an asset. Your people are assets. The building that you're in is an asset. All sorts of things.
Okay.
So and even like the threats and vulnerabilities, you know, they change every day.
But I mean, let's say that there's a common threat somewhere that can we just not use those common threats? Because for asset, I can understand that for certain companies they have different set of assets, right? But how about threats? Can we use some common list of threats that everyone else is using?
Absolutely.
So that would reduce complexities, right?
You know, that's where as a organization, when you're implementing your ISMS, you would try and pick a framework that, you know, is good to work with. So for example, the MITRE attack framework. So that's a framework that has all of the, you know, some of the most common threats that an organization or an enterprise may face.
Yeah.
So, you know, you could correlate your risks against that framework. And that, you know, that's broken down. I think it's like 15 categories or something like that now. So, you know, you use the industry standard frameworks to try and simplify it where possible.
So it means that there's no complexity here then. I mean, if we can use some off-the-shelf sort of like framework and enumerates to their threats, then what's so complex about this?
Well, you can use a framework, but you still have the complexity of classifying. So, you know, for example, let's see. So on the MITRE attack framework, one of the initial access threats that it has is trusted relationships. Now, a trusted relationship, you've got to go through now and try and classify your assets that have a trusted relationship.
Yeah.
And I think that's where the complexity comes in.
Yeah. I think, well, I mean, my original question is asking about the challenges, and complexity is just one of the challenges. So, I mean, it might not be necessary to reduce everything to complexity. So, maybe another way to ask is that what are the challenges in identify the threats, even when you have such a framework to build upon? Like they give you a list of threats that you should go through, right? But why is this not solve the problem yet?
Well, I think it's validating them. I find that's a real big challenge because, you know, a lot of when you're dealing with risk, you're dealing with hypotheticals a lot of the time. Unless you're dealing with an incident response process where something's already happened. But yeah, a lot of what we deal with, it's very hypothetical, and it's a, you know, it might happen or this may be possible.
Yeah.
How do you validate it? Do you go and test it yourself? Do you have an internal pen tester that can do
it? Probably not.
Yeah,
right?
well,
probably not.
Or do you just you make an assumption and you run with it?
Yeah. So I guess another way to frame this challenge is that it requires a lot of domain knowledge, a lot of experiences to identify which one is relevant to you, right? So you are given a list of very generic threats, and your job will be to sort of like prioritize them and to see which one is relevant, which one makes sense in my setting. And that is not an easy job for anyone to do. You need to have experience to do this, right? That's why I think many of the people who taken the roles of like risk related roles, I think they spend a few years in the organization. It's difficult for people like fresh people from outside to make an impact here. I guess you need to know how the company is operating,
Well,
right?
that's where you,
yeah.
that's where you're like me, and you've got to leverage. You've got to find your MVPs, your or your SMEs, your subject matter experts within an organization, and you just got to drill them.
Yeah. So, but it takes time. It takes time, and it takes time to build such knowledge, right? And that's why it's challenge. That's why challenging is you cannot take something off the shelf and solve this. You need to train people. They have to go through enough of experience to identify relevant and important threats. Andres, yep, you want to chime in?
Well, it's probably most of it
Yep.
been already said. What I want to say that basically the complexity begins because as a security expert, you have to know the system at least on a level of you can manage it yourself, because otherwise you can just will not understand what the system do and how it can be exploited. So, and there are so many systems. So if you are just a IT professional, you usually have your own domain where you work, and it can be lots of people working in this organization doing different roles. So they only need to know some amount of IT only which lies to them, but a security expert has to know all of it, and especially if the person wants to provide a service for other companies, every company will be different, and the list of assets will be different every time, and obviously one man just cannot know it all. So that becomes a real challenge to even understand sometime what is the system is about and what are threats and what are problems. Second, it's not only the systems are in danger itself, so it's not enough to just run a tool would say that this is a version of that, and the version has this non-security vulnerability need to be patched, because also integration part can be in danger between the systems. So it might be both systems actually are still secure, but the way they use is not secure in this particular instance. It can be again that because again the second problem is this ever-changing world, and security new security threats are found every day. So you have to be up to date. You have to always be like one step ahead everyone if you want to be a really good security expert. And it's actually, for me, it's really hard to find an expert, let's say a pen tester, because I get lots of emails, lots of requests on LinkedIn from companies saying like, we can test your system, but there's no real tangible way to measure how they will do it, because it's so easy to just find a bunch of those tools, run them against the system and send a nice report and ask for money. And I'm afraid that's what most of them actually do. You like, if you want to get a real good pen test, I guess the only good way of doing so would be a personal connection and recommendations.
Yep.
Like,
Anyone here in the audience want to apply for such a job, just contact Andres. Yeah, thanks, Andres. Thanks for sharing the experience. Yes, Marshall.
Yeah, I just wanted to add that another challenge for doing cyber risk assessments on an organization is basically that the organizations by nature are not static. So keeping up with all the different, there could be multiple new initiatives running simultaneously, and keeping up to date with all the different initiatives and being across the new initiatives across the organization, running those risk assessments and essentially not slowing down business operations to complete the risk assessments. That there needs to be a unified nature between that and the risk assessment. And the other part is the likelihood. I just wanted to add that that's not really an exact science. What one person says is a likelihood versus it's really up to the assessor to make a sound judgment on that.
Yeah, that is true. I think many of this part is very subjective, and that's why we require expert, right? That's why we cannot give a job to anyone. That require expert. Yes, but
I think one of the other challenges would be what priority does the business give? So each of those underlined, looking at an asset and then, what vulnerabilities each of those assets have. Now, that asset as well, what threats are out there that could potentially impact and leverage the vulnerability of the asset. What is the likelihood of that happening? Now you will arrive at a risk. That's a lot of work. And then you take that to the business leaders and they go like, well, it hasn't happened yet. So, I mean, there is a certain limited amount of budget also. There's that money and prioritization factor as well that makes it really challenging because all assessing those threats, the vulnerabilities and the assets, they're all very technical stuff. And then you have to water all this down to a very business friendly language. And in the end, you probably have to make a statement that if you don't fix this, Mr. CEO, it's going to cost you this much if this happens. And the likelihood of this happening is this percentage. And then they might still go like, well, how long have we had this system? 10 years? It hasn't happened yet. So, okay, we'll look at it maybe next year. I think we first spoke about complexity. Marshall just spoke about the fact that businesses are not static. And then I think we can add business prioritization as a challenge to cyber risk as well, because all that requires a lot of work. And in the end, out of the 10 reported issues that have been identified from this cyber risk process, maybe one or two of them might be selected to address in the short run, for example.
Yeah. But I thought, I mean, okay, so let me counter this because I understand the gap between the business language and the technical language, right? But isn't the goal of risk management is to, I mean, the business people talk in the language of risk, right? So that is what we are doing here. Try to use their own terms, right? So that's why we try to quantify it. And isn't that the goal? I mean, isn't that what we're doing here? So what is what do you think is still the challenge?
I think it's one thing analyzing and assessing what the risk is. It's another thing implementing it.
Okay. I understand.
So a lot of times the implementation is not budgeted because we don't know what the issue is, and that's where cyber risk comes in. And then suddenly you do this process which is relatively cheaper than implementing each of those, let's say, controls. I think policy and the assessment part is not the overwhelming cost of cyber risk mitigation. It's when you're actually implementing each of those controls, because then you have vendors involved, and then you have delivery teams, and then you have maintenance. Those are crazy amount of costs on their own. And then when you approach business with that, they go like, oh my God, like this is a multi-million-dollar endeavor. So then it becomes a function of, okay, now what's priority? Let's focus on that. And then you're left with a lot of stuff exposed, but you're aware of it.
Yeah, I think now I understand the point. So I think you agree the value of having a risk as a number, but then you worry about the costs that are associated with implementing it, right? And even though if the risk is high, but if the cost is too high, then then maybe not really sit well with the management. So so that I understand. So putting risk in like in operations and it's hard. Okay, it's great. Great discussion, guy. Thanks for sharing. And I agree with all of the assessment on the challenge here. I mean, we can throw in the vulnerabilities to the complexity as well, because for each assets, right, to keep track of the what vulnerabilities out there for each of the assets, it's not easy. Right? I mean, you have to understand the asset first, and you have to understand cybersecurity threats and cybersecurity practices and software vulnerability, hardware vulnerabilities, new trends in order to have a good list of vulnerabilities. So yeah, so all of these three, identifying threat, vulnerability, and the assets are challenging. Okay, and that is what we are doing for this workshop. So that's, yeah, so let's try to do the hard things, right? But before doing that, um, risk management is a complex process, and you will see, let's see later what is it entails. But basically it's considered a few main steps. The first step is assets, like identification and assessment, and this step ask you to list out, to view a table of all the assets that is relevant, and that you want, that you think are relevant. Okay, so yeah, so this is the table. There's a name, there's an inventory table, and you put some tag and the type some information about the asset. The next one is about classification. Put some label, some very high level label to the asset, like whether it's accessible to the public or private or sensitive or confidential. This is straightforward. The one is less straightforward is asset valuation, where you want to put some value to the asset. Now here is where the subjective judgment come in, right? Where every two person will have a different valuation of the same asset, because the valuation can come from economic, like value, like how much money this asset is generating and how much it costs to maintain and to purchase. It could yeah, it could be could include operational value, in the sense like how it helps the company to run, right? And it could be strategic value and how it align with the mission of the whole company. So this this one, to put a value on the asset, there's no formula, there's no algorithm that you can just run and give the name of the asset and hoping it will give you the number, because some human will have to do it, right? And he had to go through some sources like market research, industry report, and I think personal experience as well, yeah, to put some value into the asset. And the example of the value can be qualitative, like you can say it's high value or low value, or you can put a number to it. I think it's best if we can put a number to it, like 32,000, 35,000, for example. And then once you put the value to each of the assets, then there's another subjective step which involve like a large amount of human judgment, which is called asset prioritization.
Yeah, I think we've lost audio there.
Yeah, I think I
Oh, there we go.
sorry.
Yeah.
Yeah. I think you can hear me now. How long did I go mute? Like a minute
Yeah,
or so?
2 minutes.
No,
Yeah, about 2 minutes.
2 minutes. Oh no. Okay,
so it's
so
basically when you started the asset prioritization.
okay. Okay,
Yeah.
so the asset prioritization, I'm just uh, like saying it again, is that it's another subjective step where you give some weight to some of the values, some value of the asset, and then you multiply the score with the weight, and then you add them up. Okay, so this help to rank the assets. So not only by their values, not only by the value, but it's also on like the priorities on how the company see this one as a priority. So the asset valuation is the valuation in itself, but this prioritization take into account like the importance that the company give to this asset, right? And deciding on the weight here is purely subjective, okay? And there's no formula here either. It really depends on like the person with the in-depth knowledge of what the company wants. And then after that, you sum up the weight and then you rank the score. Okay, so this is the first step. You end up with a list of assets ranked by their priority. Which one is most important to the company? Okay, so the next step, the second step is threat assessment. Basically, you extend the table with more columns, and for each of this assets row, you list a few threats associated with the assets, right? And the threat here, I think you have done the threats in assignment 1, so you know what they are, right? But in this table, it's important to, I think it's not necessary, but is important to have a column called actor here, so you know who would like most likely be involved with in this threat, like who the enemies are. Yeah, so in this table, we have for each of this asset a few like 2 or 3 threats, and then the likelihood of the threat, like how do you think how likely it's going to happen, and the impact of the consequence of it happening. And then you multiply the likelihood with the impact, and then you have the risk score, and then you sort them, and then you have the rank. Okay, so this column, the threat column, the content of the threat, the likelihood, and the impact are again subjective. Again, rely on human judgment, right? And yeah, so the next step after you have the threat assessment is a vulnerability assessment. Basically, the vulnerabilities corresponding to the threats. So you have the threats. Now you describe the vulnerability that can be used by the threat actor to turn, to turn this threat into reality. Okay, to execute this threat. So for example, the vulnerability could be weak password, for example, and the threat could be data breach. So the vulnerability is corresponding, the vulnerability of weak password correspond to the threat of data breach, because data breach can happen by exploiting weak password. Okay, so you do vulnerability that correspond that can be exploited by the threat identified earlier. Okay, so let's just ignore the control for now, and the ultimate table that we want is this table, what we call the threats vulnerabilities asset, or TVA worksheet, which is a matrix that lists all the relevant threat to the assets, right? And each of the cells here contains 1 or 2 more vulnerabilities. So you can see this as the ultimate like table that describes the security posture of a company. This is a very important document, right? I mean, you can imagine someone's coming to like intruding Google to steal this. I'm sure like big company, they have this big table somewhere, and this big table contains a lot of confidential information. It describes what is the priorities of the companies, and yeah, what assets are available, and what the company are likely to do with those threats. So this one, yeah, it's like the blueprint of the security program of a company. So this is very important, and it's the ultimate output of the risk assessment process. Okay, so in the workshop we will work on this table. But before that, let's go back to this framework, right? Let's go back to this framework. And now, thinking back on many of this step that involve humans, you can see that many of the columns in the tables depends on human judgment, right? So in a companies, that is why we have to set up governance here to keep the people accountable for their decision, and the decision that people make related to risk assessment are very important, because at the end, if this table here, if this is rubbish, then it means you have no security, right? So you have to make the people who work on this table accountable for their action and their decision. And that is why most of the framework, risk management framework, it comes with some governance and support. Yeah, so that like outline clearly who is doing what and keep the documentation of all the steps in this risk assessment process. Right. Okay. One more thing before we go. So we can see a few steps that that I described in order, right? So first is assessment, followed by threat assessment, followed by vulnerability analysis, followed by control assessment, and at the end we have the table. So the order seems to be like this one first, this one, and this one. Okay. Let me ask you this question: is this also, does this make sense to do vulnerability analysis before threat assessment, or should we follow this order in the process? So the order here is assess, threat, vulnerability, and control. And my question is, can we make the order like assess, vulnerability, threats, and then control? What do you think the advantage or disadvantage of that, or that order, or it doesn't matter?
I think you've got to stick to that order.
Why?
Because
Why?
well, it's not embedded in stone, but it's going to guide you. So once you have your assets, you can then focus on threats related to those assets. Once you have those threats, you can then focus on vulnerabilities that are relevant to those threats. They sort of lead into each other.
Yeah.
You don't have to, but what it can allow you to do is to prioritize, as was said earlier, to prioritize what's important. Like what's the what can you dedicate resources to for the really important stuff, and what could potentially wait till later? Because you could have a really low risk threat on an asset versus high risk threats on an asset, and you want to be able to prioritize them, because a high risk may have multiple vulnerabilities. But the controls that you apply to the high risk could also mitigate the low risk stuff. So this is where it's sort of, I think there needs to be an extra step to that where it forms a cycle.
I mean, it does form a cycle in the big picture. I mean, if we go back like this, it does have a picture circle here. And we only zoom in into the framework implementation.
Yeah, because like once you've done your controls and your assessment, then you do your implementation, and then you start the whole process again, and you just sort of keep going round and round. But if you tried to do it the other way, if you're like, oh, we've got an asset, and here's a list of controls that we want to do. Now that's possible, but what you'd be relying on there is things like, for example, the Australian Cybersecurity Centre, they actually offer images and configuration policies for controls for like Windows 10, Windows 11, all that sort of stuff. So you would have to go, okay, well, what's the industry recommendation control, or what's the industry best practice, or what's the manufacturer's recommended controls? It's not going to be tailored to your own, threat or risk appetite. You're instead going to just do best practice, and that's doable as well. You could do it that other way.
Yeah, I guess it's always doable. Of course, I think if you only consider whether it's doable or not, whether you arrive at the same table at the end, then and it looks like the order doesn't matter. But I think the order affects some sort of like the effort that you put in to get to that final table. So let's hear from Babak. What's your comment here? Hi, Babak. Yeah, you want to
Yeah,
offer
sorry.
your opinion on this? Yeah.
I think I was on mute. Yeah, I would agree with Connor. I think it and the established system, which is asset assessment, threat assessment, vulnerability, and control. I think it's got to do with sort of, you know, you don't want to reinvent the wheel. You know, it's a lot of these threats are out there. It's been multi-parties have identified these against standard assets. So if you do vulnerability, perhaps first you're looking inward and you're relying on a few people's knowledge versus the, let's say, the global knowledge. So I think it makes sense to start with threat assessment. That'll be faster, more efficient. There's plenty of knowledge out there. And once, and by the way, once you have that threat assessment, it's unlikely that you will quickly cover all those threats unless it's a super critical asset. But I think that once you have done that and you really want to take it to another level, then it might be worth looking vulnerability first. But I just don't think that's typically. It just makes more sense to not reinvent the wheel and go with what's out there. I think.
Okay. Yeah. So let's not disrupt the status quo, right?
Kind of, yeah.
Okay. Okay. It's ain't broken. So let's not leave it. All right, Marshall. Yes, you want to comment on this?
I think this order makes sense, being that you're first identifying what needs to be protected. So that's your assets, what needs to be protected. Then it's what do you need to protect them from, which is your threats. And by understanding what you're protecting your assets from, then you can look at, okay, what vulnerabilities, is there any vulnerabilities that can be exploited from these threats? So I think it's really the only way that really works. And then obviously the controls in place after that. But yeah, I only see it sort of this sort of process. You can protect it from certain vulnerabilities before looking at threats, but then you're not really getting a full picture of what you're protecting.
Okay, all right. I think that is a good point. I think you see it as a natural flows of things, right? So threat first and then vulnerabilities. But what happened if I start with the asset and I list all of the vulnerability with these assets? And out of these vulnerabilities, I mean, I will see what threats are out there that can exploit these vulnerabilities. So I can still be complete, right? I will not miss out on anything if I was to do this. But I think, what do you think the effort if the effort will be if I were to adopt that approach? I mean, how many do you think, what is the number of vulnerabilities compared to number of threats out there? Which numbers are bigger?
Yeah, definitely the vulnerabilities.
Yeah. So what happened if we start with the vulnerability first and then do threat second? Then do you think it'll be more efficient than if we start with the threat first and then vulnerability next? In terms of the like number of things that you have to consider, right? Number of things that you have to analyze.
Well, I think you could start with vulnerabilities if you want to, because there are a lot of vulnerability scanning tools that you can use commercially. But the problem with that, like, that's very much like a spray and pray approach, in my opinion. Like, you do want to remediate all possible vulnerabilities across your organization. Certainly you can classify them as high, medium, low, whatever, but it's like dealing with CVEs and, reported vulnerabilities. A scanner can pick up and say, oh yes, you have this vulnerability on your network because you haven't patched A, B, C, or D, or because you have this piece of software, etc., etc. But none of it takes in, when you're purely approaching it from a vulnerability standpoint, none of that then applies. Does that vulnerability actually apply to you? Is it actually a threat?
Yeah, that is true. Yeah, that's what I'm.
You can have a critical vulnerability on your network, and depending on your configuration, you could have absolutely no threat from it whatsoever.
Yeah, that is true. So I think to rephrase a point, it's just like if you start with the vulnerability first, there's many of them to go through, but at the end you only pick a small number of them because of the threat that is practical, right? But if you start with the threat first, then you start with a small number of threats, and then from that small number of threat, you only need to study a small number of vulnerabilities. So it seems like you apply big filter if you do threat assessment first, rather than if you do vulnerability analysis. And I think if we look at that way, then it saves some effort, because so search, you can imagine that what you do is to search for this table. There's a comprehensive table at the end, and the search space is just huge, right? There's a lot of things. But then if you apply big filter to it in the earlier steps, then you can narrow down the search. It'd be more guided, and then you arrive at the table quicker. And I think at the end you will still arrive at the same thing, but it's this amount of the effort that you have to spend on going through all the vulnerabilities of all the assets, and then later realize that okay, it's not relevant because some of the vulnerabilities requires quantum computing to tags, and none of my enemies has access to that computer, so it's not really applicable, right? Any other comments on this? So there is some reasoning. There's some good reasoning behind this order, and for once, it is good to stick with the status quo. Yeah, right. Okay, so that's enough. Okay, yes, Andres.
Well, I just thought about if we start with the threat assessment, challenge would be to actually know your threats, because not everyone can guarantee that they know all possible threats which they can be happening, and in this way you can overlook some of the issues. So I would probably still run the port scanner first, just to see the ballpark or whatever, like whatever actually is there to deal, and then maybe assess from that what are tangible, what are actually threats which can be dangerous and can be actually used. And then again, with this refined list, I would start going for vulnerabilities in more detail. So I probably would do a mixed approach in this case, because I cannot say I know all threats and I can just name them from my memory.
Yeah, that's true. I think as again, I assume here that I assume in my discussion, my argument is that threats are known. So, but yes, you correct. You are perfectly correct that it's difficult to sometimes it's difficult to know the threats, right? Or to enumerate all the threats that are relevant to you. But if you run a good business, you should know who the enemies are. I think. Um, yeah, I think you should know who is out to get you. And that is a good start to enumerate all different kind of threats. And in this workshop, there's a table. I would show it later to you guys, but let's discuss the scenarios of this workshop that the discussion will be based on. So the case study that we're going to discuss is a Metro Geelong is a online business, retail business. It's like the poor version of Amazon, and it's located in Greater Geelong, specialized in healthcare products. And there's some statistics about the companies here. The online customer portal is where the clients can place order, tracks deliveries, and ask product specific questions. And the employees of the companies, which is like 500 of them, each of them have a desktop workstation with Windows 7. Okay, so let's assume that this case study is not old, right? This is a recent case study, and some of the workstations still running Windows 7. They also use Foxit readers of this particular version. Yeah, so you should be suspicious when we give you very specific details here, the version numbers, like the major, minor, and the patch numbers and things like that. This reader is a multilingual PDF tool that can create, view, edit, sign, and pin PDF. There's UT, the IT team responsible for system operations. There's the accounting team for financial accounting, and the inventory team for really replacement and fulfillment of the client order. So it's like a small scale version of Amazon. So there are three tasks corresponding to 3 steps that I described earlier. That, and at the end, what we want is a big table at the end, right? And the first task is asset identification. Okay, so from this case study, please identify 3 important assets to you, and yeah, and determine the relative value of each of these assets and prioritize them. Yeah, of course, this one is purely subjective, but please give some reasonable explanation on the priorities and the rank. Yeah. The next task is, once you have the asset identified, you need to do threat assessment. So for each of these assets, so please identify few threats and be specific on who the threat agents are, like the people who actually execute that threat. Okay, and then prioritize it. And this, you have a we give you a hint here. It's based on this book, based on the textbook in the course, because there's many different kind of threats, right? So where do we start? And this table 6.363 in this book, let me refresh it. In the book, this book we can access online, right? So there's no piracy here. Let me bring it. I should have brought it earlier. So 6.3 is a table that lists all the common and most frequently found threats for information security. So this is where you can start to like narrow down those search to identify what threats are relevant to you. Yeah, table 6.3. Okay, so just go to this book and let me see, where is it? Oh no, I can't. Okay, so 6.3. There are some threats. They are grouped by categories, like software threats, like espionage, compromise of intellectual property, sabotage, technical error, software, technical hardware, the technical obsolete, and theft, like many different kind of threats. Okay, so this is all good, give you a good start. Okay, so use that table to guide our identification of the threats to the scenarios. And task 3 is, for each of these threats, I identify the vulnerability that can be exploited to turn that threat into reality. So what are the possible vulnerability that that can be used for the threats? Yeah, and it gives you the it gives you the reference to table 6.7 in the textbook. So 6.7 basically give an example of the vulnerability for the DMZ router. Yeah, some of the vulnerabilities here corresponding to the threats, right? So you can do the same. So you list a threat associated with the asset and talk about and list some relevant vulnerability that can be exploited for that threat. Okay, so there's 3 tasks that align to 3 important steps in risk assessment. And let me give 15 minutes because we don't have much time. So let's so you guys can work on this for 15 minutes. And at 20 minutes. So let's discuss it about 8:10. 10 past 8, and then discuss some of the assets that you identify and see how you would rank them and what assets are important to you, what threats are important, and what are the vulnerabilities. Okay. So I put the
which page is table 6.3 in the book?
table 6.3, I think
339.
339 is 6.7, 339 is 6.7. I think
Oh.
the other one is, yeah, 333. Yeah, it's quite simple.
Nice.
Yeah. Put it in here. Okay, welcome back everyone. Let's get started. Anyone want to go first on discussing the top 3 assets and how you rank them by their importance and value to the Metro Geelong company? A lot of information assets here, right? So yes, Babak. Yeah.
I didn't get too far. Took me a while to think about it, but I identified 3 assets. One is to me, the most obvious one was the customer portal as the most significant asset
Okay.
of the company. Now, I didn't think granularly because that requires a bit of thinking because customer portal entails, the databases, the servers, the software, blah, blah, blah. I just assumed it as a single asset.
Okay.
And the asset type would be it's essentially software, a web application. I'm thinking about the customer portal as a web application.
Yep.
In terms of classification, it is public. The web portal itself, it's public facing.
Okay.
In terms of the value to that, I just assumed 5 million initial setup cost, 2 million annual maintenance and admin cost. The operational impact is 50 million per year. Because they have 50 million, and it looks like from the context, all their business is coming through the customer portal. And data sensitivity, I put it as 60 million because I'm assuming 50 million in terms of if there is a privacy breach and the data is exposed, that's the Australian maximum potential impact. And another 10 million if customers want to, sort of take it a bit further in terms of damages. So it's a whopping 110, 15, 117 million dollars of value to that asset.
Yep. It's a very high
the
number.
Other two, it is a high number because I mean, what bumped it is really the operational impact in a sense that it, based on the case, it looks like all their revenue is coming through the portal. So, and they have given a value of 50 million. I'm not sure if that's the correct way of assuming, and this is just annual.
Yeah, that's just some number, right? You just need some justification to some number, and no one can say that is the wrong number. And but I think it makes sense. Makes sense too.
Yeah, because I mean that's just annual. I'm not even thinking long term. So and then data sensitivity. I mean, what sort of sensitivity are we talking about? If we're talking about privacy, there's the first thing that comes to mind. It's potentially custom. It's a web application. It can lead to injection attacks and cause a lot of costs. The other 2 assets I identified, but I didn't get the time to do the classification, etc., is the customer information itself.
So that is not part of the portal. That you would say that is not part of the portal.
I think, the fact that I'm considering data sensitivity, maybe that can come in this part, in the customer information part. It is part of it, but customer information is stored in the database that is the backend of the portal, but that asset type is information and the classification is sensitive in that regard. I wouldn't consider the customer information as a public facing information. So I think if we want to separate it, I'm just assuming.
That's fine. I think there's a reason to segregate them based on their sensitivity layers level. Okay, so so you can put some number to it too, but let's see, let's hear the third asset then. What would be the third one?
The third one, I could have considered stuff like network stuff, but I didn't. I took the workstations.
Okay, very interesting.
Only because only because I mean they're using Windows 7, which is not supported by Microsoft anymore. So it'll be interesting to assess it from a threats perspective down the line. Yeah.
So it's important to pick up the low-hanging fruit first. I think the desktop has a lot of interesting threats and vulnerabilities. But yeah, so can you share what threat you think would apply to the workstation?
When it comes to workstation, the first initial thing that comes to mind is what's given in the case. It's Windows 7 based. I think it's not even supported by Microsoft anymore. So the vendor does not support the operating system anymore. That exposes it to a lot of threat and vulnerability. I haven't done this part yet, but I'm just thinking out loud now.
Yeah. Does anyone has anyone thought about the threat for the workstation, and you want to chime in? You want to add into this?
Yeah, for me,
Connor,
it looks pretty.
Yeah. sorry, Andre. I saw Connor's hands up first.
Yeah, I've got, so just for the workstations themselves, because of the installation of that Foxit reader, there's 1, 2, 3, 4, 5, 6 high CVEs associated with that version of Foxit reader.
So let's talk about the threat. Can you name the top 2 threats, for example, for the workstation, and then we can have a field day with the vulnerabilities. Let's have a threat first.
So the threats then for the workstation would be for compromise. So that would fall under, I guess, a software attack, or the threat of espionage or trespass.
Okay, I mean this one is only the categories, right? But you can be more specific. Like for example,
so you'd have,
software attack. For software attacks, what sort of software attack are you thinking of most relevant in this use case?
So I'm thinking malware or remote access Trojan.
Okay. Yeah. And what are the vulnerabilities that can deliver that threat, you think?
So the vulnerabilities there are the CVEs through the Foxit reader.
Okay, can you share more detail on how those CVE can enable malware? Like how would it work? That side.
Yep. So the attack path that a actor would follow for this would be crafting a malicious PDF file that has embedded JavaScript code. Now
JavaScript. Okay.
Yep. Cool. And so that version of Foxit Reader had a functionality built into it that allows it to run some JavaScript code in the back end. Now the vulnerabilities that exist are because it allows the running of that code without validating the operation first, or validating that there's anything there to run the code against, basically. Okay. So it's a remote execution vulnerability that requires, all it's going to take is for that email with a malicious PDF to be received by one of the workers. They open it up, it's going to automatically execute the code, and then it's going to could potentially download something from the internet, could install malware, that sort of thing.
Yeah. So can you elaborate on how that email got delivered? I mean, through what attack vector that the attacker can deliver that payload?
So that comes through the Microsoft software suite. So that says they've got Word and Excel, but if it's the Microsoft software suite, then they should also have Outlook.
Yeah.
Alternatively, because there's a customer portal where they orders can be placed and such like that.
Yeah.
I'm assuming that they would be able to upload files as well.
Yeah. But how would it get the employee to open the EF?
Well, you masquerade it as an invoice.
Okay. So in other words, it's like phishing or scam, right?
Yeah.
Yeah. Okay, so that is a very clear part of attack that actually exploiting this reader to take over the workstation, right? So and once it take over, it can do anything, can install malware, thing like that. Okay, so that is one great very specific vulnerability associated with very specific threats. Is there any other threats related to the workstation besides sort of like remote code execution there?
Well, no doubt, as it was already mentioned, Windows 7, sorry, being end of support.
Yeah.
There would just be a plethora of, you know, vulnerabilities associated with that. So,
but what sort of threat does those vulnerability enable? I mean, so now we already cover like malware and those and anything that can deliver through FOXIT reader, right? But is there any other distinct threat from such remote code execution take over from from outside?
Well, I think from this one you're going to be looking at technical software issues. So you're going to have bugs and stuff like that, and backdoors. Technological obsolescence, as per the threat table.
Yeah,
where you've just
I
got
think those are
outdated.
like very high level description of the threats, right? But so I wonder whether we can go deeper to be more specific, like what sort of threats they are. I mean, what can they do? Yep, I mean, remote code executions from vulnerabilities is like super important, right? I mean, it's difficult to be more important than that. I agree. But is there any other threat that's coming from a different source? What do you guys think? But Andres, you yeah, I think you was about to share the comment. Do you want to add to this? Do you have other threats?
Well, yeah, definitely there are lots of threats here because even the fact that they're using Windows 7 and this FOXIT tells me they don't really pay much attention to the security, especially if you have 500 of employees, so it's a big network of people.
Yeah.
And assuming they're all using Windows 7, that means I just don't care at all what happens to the network or to the computers. And this basically there are plethora probably of all sorts of attacks from worms to basically different exploits, different ways. What's the word to pretend? So like just I forgot an English term for this. It's when you pretend to be someone else and kind of trick people. I assume this with them because it's a big company, 500 people. Probably not everyone knows everyone else by name, so you can pretend to be someone else and try to trick them to give you access. So that's it. Instantly there are really lots of different vectors. It's hard to name specifically what would go wrong, but definitely this company doesn't pay attention much to security. And as soon as they gain access even to one of those, also even the theft probably also would be a danger in this case because so many workstations. Assuming they get access to even one workstation, if this guy is not this relaxed, there probably will be passwords to the portal right there, save some ways so they can for getting access to the workstation and get access to the portal, and then basically they can steal information, they can steal customer details, they can steal financial information. So that was my take on this. Judging from the how the system looks like, I don't expect the website or the portal would be much more covered. So probably it has also security problems, security threats, which can be exploited on the portal itself.
Yeah.
I don't see why not in this case.
I think that's the fact that Windows and FOXIT reader is a world of vulnerabilities here. So I think almost all the threat is applicable. I guess.
Yeah.
All the threat is up.
Yeah, I don't know why they're using Foxit Reader in the first place, but for them, for the company like that, working with a PDF is very like a vital part of their business. They're probably sending lots of PDFs to each other on different occasions, and also clients sharing the PDFs. So definitely this would be most likely vector of attack will be the Foxit Reader. Even and not does not have to be a target attack. It can be just some worm, just sending those PDFs just on a massive scale, and then we just open it because they don't expect it can be hacked from the PDF. It's not.
Yeah.
Yeah. So that's my take.
Thank you, Andres. Marshall.
Also, as this being a physical desktop workstation, there's a number of physical threats there. So a physical theft of that, unauthorized physical access. So especially if the device or the hard drives are not encrypted, big issues there. And then there's also physical tampering, where you can you might not steal the device, but tamper with the device, add a keylogger, something like that, to track users. So not only cyber threats, I guess, but there are physical.
I think that is very interesting point. Many people got caught up on like software-based attacks, but I think physical attacks is like real threats too. And yeah, thanks, Marshall. So we cover like remote threats that go in through this Windows and Foxit Reader, and physical tampering, like it could be some cleaners and some third party, some visitors, right? But what do you guys think about insider threats, employees? Like, is that applicable here? Do you think insider threat is applicable to the desktop workstation?
Definitely, because it's lots of employees, so it would be really hard to control them all. And but totally possible that some of them will be incentivized to do damage to the company for some reason.
What sort of damage that they can do to the desktop? I mean, the employees insider mean that they have their own workstation too, right? So what do you think that they can do?
Well, the damage would be to steal because it's actually is a really profitable site with only 10,000 employees, typical customers. They're making $50,000 per hour. That's a huge amount of money, so huge amount of transactions, and basically, I assume there would be people who want to get this information, who want to get insiders information how this revenue is achieved, who want to get the hands of this loyal customer database and market them as well, who even probably might want to get the hands on the cash flow, on the money, and all of that because those 500 employees, they all have access to the system, to the portal for that day-to-day task. That becomes instantly a huge threat because it's by the nature you cannot really protect from all of them because you have to give them access to that information they need it for work. They cannot not have it. But if there's no system in place to account for that and know who does what and who access what, instantly that becomes a really easy way to steal this data and really hard to protect from that.
But in the example, they use a desktop as a means to get into the portals and get into the customer database. Is that right?
Yes, well, because it's online thing, they don't really have to use the desktops to do it. They can do it from anywhere in the world. And this means they can share their password with someone else who will do the damage. And as I said, it will be really hard to find out that pinpoint who did the damage if there's 500 of them. You need elaborative logs to even track all of this traffic.
Yeah, but my question is more in relation to the desktop workstation as an asset. So what can what sort of damage to the workstation can an insider threat? I mean,
well, the workstation itself probably doesn't have much of the value per se as a unit, because again it's 500 of them, so destroying even like some number of them probably will not seriously damage the operations, but all of those workstations probably have some level of access of the data. So stealing this access, stealing the data, stealing the private information would do the damage.
Yeah, I think that is a correct way to look at it. So I think most of our workstation is managed by the company, right? So if the employee can manage to bypass any of the restriction on those workstation, then they can do something. They can steal. There's some valuable piece of data in the workstation for them to steal.
I assume with Windows 7 it's actually not hard to bypass if you know your way around it. It has lots of options to elevate your level of access secretly.
Yes, Marshall, you want to add more to the discussion?
I just wanted to add, we're also assuming that these desktops do have some sort of protection and some sort of login system. It might be, not domain joined and just a local admin rights. It doesn't specifically say there how protected these workstations are.
No, so that's why you can make some assumption and talk about them. But I can imagine for the companies, most of the employees' workstation are managed. I mean, they cannot afford to let people like bring anything to any install to the desktop. I think it's a
livelihood. Judging at Windows 7, I would expect a worse in this situation unless it's stated that actually there's a system. I would not expect it to be one.
Yeah. Okay. Yes, Babak, I think you raised your hand earlier. You want to add in something real quick?
I mean, I think we covered a good lot of stuff. I mean, there's a lot that we can assume here. Things like human error or failure. Insider threat can be intentional or unintentional. The fact that it's Windows 7 based, they can just put in a USB that might have viruses that they're not aware of with Windows system. That's not, with a lot of vulnerabilities, it can cause issues. That could be unintentional, sort of issue.
So I think if you are a risk analyst and you look at this case and you are given this case, and I think you'll be quite happy because I think there's a lot of things that you can put on the top of the list, right?
I would first recommend to changing the IT team. So
maybe.
But yeah.
Maybe, yeah. But anyway, thanks everyone. I think we're out of time, so I think we can end our discussion here. But thank you a lot. Thanks a lot for sharing the experience, and I learned a lot from you guys, as always. So have a good day, and I see you guys next week.
Thanks, Good. Have a
Thank
good day.
you. Thank you.
Cheers.